This video is for my third type of simple chemical reaction, and this is called a single replacement reaction. In the single replacement reaction, I know I'm going to recognize this because I'm starting off with an element plus a compound. Whenever I see as my reactants element plus compound, I'm thinking single replacement reaction. And a way single replacement, my general format would be if I have single element A plus compound XY, then A is going to come in here and it's going to replace either X or Y. And the question is, which one will A be replacing? And it's a simple format. Metals replace metals. And nonmetals, sorry about that, nonmetals replace nonmetals. Alright, so let's look at a simple example of a single replacement reaction. Let's say I have something like aluminum plus sodium chloride. So I recognize first off that this is a single replacement reaction because I have an element aluminum plus a compound sodium chloride. So my single element aluminum will be replacing one of the elements in this compound, either the sodium or the chlorine. And aluminum is a metal, so it's going to replace the sodium, which is the metal in my sodium chloride. And as a quick reminder, whenever we have a compound, an ionic compound like this, the metal is always the first part and the nonmetal is the second part. So this will look like aluminum coming in and replacing the sodium and kicking poor sodium out. And I'm going to have sodium by itself plus aluminum chloride together. And I need to make sure that I check for the formula of aluminum chloride. Aluminum is +3, chloride's -1. So it'll be AlCl3. So the question is what would you think if you were sodium in this reaction? I mean, look, you're so happy with this chlorine. Would you want to be replaced by aluminum? Are you just going to allow aluminum to steal this chloride ion that you've been with? And the answer is, well, maybe, but not always. And it's an important note for all of my single replacement reactions is that you need to check your activity series. Every single replacement reaction, you should always be checking your activity series. So who will win in a fight between aluminum and sodium trying to win the chloride here? And we look to our activity series and we see, well, sodium's actually higher on the activity series. So if sodium's higher on the activity series, that means it will win this fight. And if it wins that fight, that means that when aluminum and sodium chloride come together, there is actually no reaction. So we always have to check to see whether or not that single element will replace the other one. If it's higher up in the activity series, then it will be able to replace that element. So as another example of this, if I have hydrochloric acid plus zinc. And I looked at my activity series and I say, all right, I'm going to compare my zinc and it's going to be trying to attack my hydrogen. And zinc is higher on the activity series than hydrogen, so that means that zinc will react with hydrochloric acid. Not all metals, when you put them in an acid like this, will react, but because zinc's higher up than the hydrogen, it will. So zinc's going to come and attack the hydrogen, and zinc is going to win the chloride here. So my reaction will look like this. I'll have zinc with the chloride and hydrogen by itself. It's important to note that hydrogen is diatomic, so it has to be H2. And the correct formula when zinc and chloride come together is ZnCl2. Once again, zinc is one of those transition metals that has a constant charge of +2, chloride is always -1. So when I cross and drop the charges, I get my ZnCl2. Alright, another variant of this type of reaction is whether or not something will react with water. And we know that just the top 4 from the activity series we used in class will react with water. So if I take one of those top 4, like sodium plus water, then sodium will be able to kick out this hydrogen in the water. And this reaction is made much easier if instead of writing water as H2O, I think about water as HOH. And so sodium will come along here, kick out this hydrogen, and take the OH group. And when you write water as HOH, it's easier to see what my products will be. It will be sodium with the OH group plus hydrogen by itself. And once again, hydrogen's diatomic, so it's H2. If I look at the charges of these to make sure that my sodium hydroxide is correct, sodium is +1, my OH group is -1, and I know that OH is -1 because either I've memorized that hydroxide is -1 or I looked it up on my polyatomic sheet, so I see that in fact this formula NaOH is correct as it's written. So only those top 4 on the activity series, once again, will be able to react with water to be able to form that hydroxide. Alright, and then another variant on my single replacement reaction is throwing in a nonmetal. So if I have something like sodium chloride plus fluorine, and once again, fluorine's diatomic, so I'm going to write this as F2. I know this is a single replacement because it's element plus compound. Here, my single element fluorine is going to come and attack the nonmetal in sodium chloride. It's going to attack that Cl group. And here's the question also of whether or not this will happen. And my rule for the halogens on the activity series is that if you are higher on the periodic table as the halogen, and fluorine is above chlorine, then the reaction will take place. So now sodium is going to be grouped with fluorine, which is not how I wanted to write that. Sodium and fluorine will be together, and poor old chlorine is left by itself. Need to check my diatomics, and chlorine is diatomic, so it's Cl2. And I need to check the formula of NaF to make sure my charges are balanced. Sodium's +1, fluoride's -1, so it stays as NaF. Alright, so once again, these are my single replacement reactions. I know that I have a single replacement reaction because I'm starting with an element plus a compound. If I wanted to finish off what I started over here with my general format, A plus XY, then if A is a metal, A will replace X, and I'll get A paired up with Y plus poor X by itself. And you always have to check the activity series with single replacement reactions.